Hi guys, welcome to Learn Electronics Repair. And having had some success with the last couple of amplifiers we looked at, well, one amplified mixer fixed, one amplifier Citronic tested working, just needs the correct fuses fitting. So I have another one. Yeah, this one, Core Boy. Yeah, I like that. Core Boy. CA-1200 audio power amplifier, 1200 watt I would imagine. Another one that is very, very heavy. The customer is one who brings me quite a lot of amplifiers to repair. I'm fairly sure, and this is the same guy who brought those motorized moving headlights as well, by the way. Yeah, so I'm fairly sure he said smoke was coming out of this or something was burning. Yeah, he is Spanish, so maybe, yeah, his version, how it translated, isn't correct. But let's have a look inside this one before we do anything else with it. Okay, let's have a look. Well, I see what happened. Okay, he's correct. Smoke came out this side. There we go. So that's what's happened to our amplifier. Quite a bit of damage here in actual fact. Of course, the good news is we have the working one. I think he did say one was working, but again, maybe he just said one isn't burnt. Okay, so I think the best thing to do with this is to take the two amplifiers out, because that doesn't look to be very difficult with this. We'll get them on the bench. We can have a good look to see what's happened to this one. Okay, I've removed the burnt channel, so you can see there. I think what we'll do now is leave this one in. I'll power this up with just the one amplifier module. Okay, if this one works, I'll probably just leave it in there for now. If I need to refer to it to fix this one and I can't see what I'm doing with it in, I can always take it out. Okay, but hopefully that one can stay in there. Having said that, they're quite simple to remove actually. The only thing is that's to unsolder these two wires. They go to like their little thermocouple or the thermal switch here for the fan. That switches the fan on. Okay, so let's power this up and let's see what it does. Light bulb is up there. Okay, switch on, power up. What does it do? Right, then going dim, so that looks okay. So we'll take that out, just powers up again. Fans running. Okay, I heard the relay click as well. Let's connect speaker and audio signal and just see if this one's actually working. Okay, let's see. So power on again. I heard the relay. So that one is definitely working. We have one good channel. So that should enable us really to be able to repair the other one. Let's have a look to see what's happened to it. Okay, so burnt. Probably one that burnt and two that just blackened. Burnt. Something around here, but this could be smoke damage. You see, that looks like it's one of these. A third one. Let me see. So on this side we have 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. That's something else. I can always get the other one. It's by the terminal resistors, I think, these ones. Yeah, we have the good channel. So that's burnt. I think let's just clean this off as best we can first, and then we'll have a look to see what we have. And we need to do some soldering work anyway, so let's just take the thing off. Yeah, we can leave these transistors on. Oh, look. Yeah. Nice. So that blew up. Yeah, that's kind of like that one, yeah. Okay. Well, those are all freed up. The other one might have welded itself in place. Let's have a look. No, it didn't. Okay. I'll just keep all the micro washers on here. Yeah. Well, you know, they were all falling off anyway, so everything's safe in that bag now. Okay. Right, I think the first thing with this is soap and water in the sink. Then let's have a look at it. Okay, so I've just got a fan here. I don't really need to put any hot air to do this, just airflow should dry it. I mean, it's 26, 27 degrees in the workshop anyway. That's with the aircon on. Yeah, but it's still October, so still pretty hot. While that's driving, I'm going to see if I can find a schematic for this amplifier. And it looks like good old Electro Tanya has got them, yeah. Service manual, CA-1200, 1200 and some other AP and whatever. I hope this is the correct one. Let's have a look. Good site this. It's always free to download. It says ZEC. That's a different make, so maybe this isn't going to be what I'm looking for, but we can try. No, this isn't the one. I can see the power transistors here, 4 pairs. We don't have that. Okay, so it's not this one. That says CA-1200. Another one there with more. No, unfortunately, I can't find the schematic. The one I found is not actually for these amplifiers. Same models, but different make, different schematic. Wrong number of output transistors. I know it's incorrect, okay. So this is drying quite nicely. We'll give it a little bit longer, and then we'll have a look to see exactly what damage we have here. Okay, guys, so it's been in the sink. Hand wash and water works really well, okay. So we can see something blown here. I think those are just discoloured, but we can test them. Then it's kind of come this way, possibly through this transistor, probably, and then through here. So I think these are small resistors. These are the emitter resistors in pairs. You see, 5 pairs, 5 transistors. Same here. What I don't seem to have on this side is that one. That is something that's only on this side of the amplifier. Okay. And you can quite clearly see this path of damage. So, because we have the good working one, I don't see any problem with actually replacing those components. We can figure out what they are. But this doesn't look good. So this is burnt into the board by the looks of it. This is a double-sided board, but the other side looks okay. And this won't have any internal layers. So we can probably clean this up enough. Otherwise, we could reroute these components. So the one that goes from there to there could be wired across from here to here and just cut this track off altogether. Yeah, so there's ways around this really. Yeah, I'll try and remove as much of this charcoal as I can and then clean this again, and then we'll see what we have. Okay, so that's that. That's the end of something. Yeah, see, get some of the charcoal off. I'm not sure what's this transistor here. Looks like something's... Oh, I think, you know, this isn't the transistor. I think what's happened is he's just blown a piece of the track out there. So that's where it comes down into here. So this is where the current has flowed. It looks like this transistor is possibly gone as well. I think something's actually breaking off that one. Don't like the look of that transistor either, but again, we've got the good one. Okay, what do we do? Well, I think the first thing we should do is look for short circuits on this. And that's probably the best place to start. Okay, diode mode. Let's look at these output transistors. So, short, short. That's all short. This all reads short. Yeah. This one reads open or weird. Okay. I said with this meter that we give you a weird reading with that triple bleep when there's something not right. There it is. Yeah, the something not right detector. Okay, let's take all these output transistors out and take that off as well. What does the side look like? Short. Not short. Interesting, I thought these would be in parallel. Probably the emitter resistors have gone as well. Are these the PMP ones? Yeah, 2SA. Again then. Short. Reads okay. Although I expected to find a lower resistance base emitter resistor, but we will see. Short. Some of these might be alright. So if they're not all reading short, but this one is short, that suggests to me that these resistors are open circuit. And they are, okay. Otherwise, if that was short, it's in parallel with the others, so it would all read short. Okay. So, we're going to have to unsolder all the transistors. Well, the power transistors. And then we've got to start working our way back. Okay, guys. So, we have all the output devices removed. 2SA1943, 2SC5200. Very common pair, these. I have some in stock. The question is, do I have enough? I may not do. And also there's a question of matching the gain on these. I think all of one lot are bad and maybe one after the other lot are bad, but then not totally sure I trust the others either. Let's see. I could use the component analyzer, but for a quick check, this shall sort the men from the boys. Dead. 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 See, much faster than the component analyzer. Dead. And we know that's blown up. That's all bad. It's a good one. Or at least a functioning one. Dead. And what's this one? 2SA940. With a solder bridge between two legs. So we'll just deal with that. So this will be PMP. All the ones like 2SA are PMP and C or MPN. Well, it doesn't look good. Okay, so that's bad as well. Those four possibly are okay. So I think I'll just put a little mark on those ones. This lot, I usually like to stick them all in a bag and give them back to the customer with his repaired amplifier. Do you guys do that? I don't often do, not on many things, but things like this I do. And some things like the little capacitor that gave me all the trouble on that powered mixer going to the Hall of Shame. Okay. Now then, With this lot, I need to check out for PCB damage, and by far the easiest way is to remove components that are kind of in my way, even though they may be okay. I mean, that one looks like it's a bit stressed to me. Yeah. So I'll get these resistors out. This transistor may or may not be faulty. We have that one resistor. This transistor looks very suspicious to me. That one's clearly gone. That one may or may not just be dirty. So if I remove the really bad ones, then it's fairly simple to, well, I say fairly simple. It makes it easier to clean all the PCB up. So let's do that. This sort of work, by the way, is where this really comes into its own, yeah? I mean, I know people comment and say, well, you can use this, you can use that, whatever. I would have to say to those people, have you ever actually used one of these? Yeah, have you ever actually used one? Because if you have, I think you'll agree with me. It's a real time saver, that. And saves a lot of possible damage to PCBs as well. Sometimes you have to get the component out to get the holes really clean. And we have some resistors, okay. These are 0.47 ohm. So 47 divided by 100, okay. And they read, well, that one's open, okay. Well, the meter's working. They both read open. We have 3 resistors. Can't read the value of those 2. This looks like, yeah, 220 and 2 more zeros, 22k. But may as well replace it. They definitely want replacing. This transistor had actually lost a leg anyway. That wasn't me taking it out. I think you can see there where it's melted. Can we see what that thing is? Oh yes, now it's stopped moving. I can read it, 2N5551. I mean, it didn't really matter because we have the amplifier anyway. This is the one that looked like it was faulty when I was looking at it in circuit. Now I can see it's definitely faulty. It's lost the entire back half of the transistor. So we'll have to get that one from the other amplifier. At least then we'll know the part number. Same applies to the blown up driver transistor as well. So to see that, I need to get the other amplifier module out in actual fact so I can actually read the markings on it. So that's what we basically have now. So this is just a burnt area of PCB. Okay, there's no tracks around there. This obviously, when it failed, it took a chunk of that out, or that took a piece of this out, whichever way. We can see this track actually blew open here. I think that one, yeah, it's gone there. Okay, this is the actual fibre, glass fibre that makes up the PCB material. Okay, so let's clean this again. Now I'm going to use the fiberglass brush to do this. Then I'll just stick it back into the sink again, and then some isopropyl, and we'll see how it looks. But it's probably going to be okay, this one. There's no point ordering or replacing the transistors till we make sure we can actually clean this up. So that's the next part of the job. Detlef gave this to me. He says he bought it and never used it. I found it really useful. So this is fiberglass, okay, like a propelling pencil, but fiberglass. This stuff is very good for cleaning off this sort of damage on PCBs. It's also horrible because the little glass fibers break off and wear away, and they get onto your bench, and then they quite happily stick into your skin. Yeah. So the trick with this, do it on something like kitchen roll you can then throw away, and don't do it on a dry board. Okay, so I find isopropyl alcohol is fine for this. And this will actually scrub away at the burnt parts of PCB, the carbonized parts, and remove them. Okay, it's fairly gentle in a way. Okay, you can see now the burnt bits of track, so this obviously all will need replacing or reworking. Once we've cleaned it, we'll figure out the best way to do that. Okay, you can see how well it's cleaning up in these areas. Obviously the piece on the left hand side is far more severely damaged. I'm not worried about these bits of track lifting up. We know where they go. Okay. So once again into the sink with this one. And now we see the results. So we have some damage to this track here. A little bit on the corner there. This one has come away from the board. So that track just goes to these 2 points here. So these, we can see here, this is just this pad. So effectively we have a resistor from here to here and then another one in series. Yeah. And then this connects to that junction. One end of one resistor is there, the hole needs cleaning, and the other one is here. Okay, I've taken the other amplifier board off and we can see them here. So these are the two resistors. Color balance isn't very good on my camera. It could be brown or red. If it's red, 220 and then times 0.1, so 22 ohms. Let's just measure that. 12 ohms, so it's brown red. Okay, that's a standard value, so I'm happy that actually reads what it is. What's this one read? Yeah, another one the same. And yet that looks more like 270. I'll probably have to just unsolder these to get a reading from them. That is 270 times 0.1 again. So that was probably a 27 ohm according to the markings. And this a 12 ohm. Okay. But we can unsolder them. So that's not a problem to work that out. You'll see in fact the two resistors go in parallel with these. Okay. These 0.47 ohm. And that track goes off under there. So we could actually do away with that center pad. It doesn't connect to anywhere on the other side of the board. Come from here, put the two resistors in series, solder one end together, and then solder a wire from there down to here where it goes. And that's what I think I will actually do. And then that effectively gets rid of the need for that. We can cut this track off here. Yeah, the two large resistors go in here and here. And then, as I say, these will just solder that end and that end and bring them up to a point here, up in the air soldered. Sort of like that, okay? Obviously, they're smaller than these. The only other track we have damaged then is this one. This is away from the burnt bits. I'm quite happy to solder this. And again, reinforce this. So what I'll probably do in actual fact is take a thick piece of wire, solder it from the end of this resistor, and solder it over there somewhere. And then that does away with that part of the track. We don't need it, okay? So we can get rid of that. I mean, we could even cut this off if we want, but there's nothing charred around there, okay? This isn't damaged really, so we can just replace that resistor. Same with that one. Yeah, those are not a problem. Oh, in fact, they're even marked 33k, 100 ohm. Yeah, they're actually marked. Obviously, those were marked, but we can measure the other ones. And then we have the two transistors. So this one, 5551, that's a 2N5551. I have those in stock. The other one lost a leg either during the incident or while I was unsoldering it. And this one, C1815 or 2SC1815, I have those in stock. And that one blew up. And everything else looks okay. But looks okay doesn't mean is okay. Or rather, it doesn't necessarily mean is okay. Let's look at these emitter resistors. So each one we know is 0.47 of an ohm, so about 0.2 in parallel. This doesn't read particularly accurately on very low value resistors, but it's good enough to tell me that one's open circuit. That one is open. We can probably take a relative reading actually, just to yeah, we just click on rel there, and then that zeros the meter. Still open circuit, of course, so they've gone. They've gone. Those ones we know are gone. Yeah, no point measuring them both because it reads open. Okay, so gone, gone. Then this side, yeah, 0.25, what you'd expect. Okay. Actually, this meter's pretty good at this value resistor. 0.26 is 2 in parallel, 0.47, so yeah. This is one where the transistor was short, and that one's gone, so the other one will be gone. So we have 2, 4, 6, 8, 10, 12 of those gone. And I think we need to take a bit of care replacing these. They look like a 2-watt resistor to me. And I have 2-watt resistors which are the same physical size or very close, but these are metal film or carbon or something. Those I'm fairly certain are going to be fusible resistors which are designed to go open circuit when they fail, not burn up. Yeah, they would have burnt up otherwise. So I need to find replacements for these. In fact, I think you can see inside it's like a metal spiral type thing. Okay, we have another one there that looks damaged. So that one, 22 ohms. What's that one read like? No, I tell a lie, it's actually 33 ohms. I can see now looking directly at it. Open circuit, okay. I'll just go into ohms range in case it's out of range. Oh, it reads 200 ohms. It's marked like a 33. How's this one read? Yeah, 33, near enough. Okay, so that's gone as well. So let's start making a list. And we have, these are the blown ones, okay? 1 of those, 5 of those, 12 of those. These I have in stock. I might have a few of these. The problem again with this is we need to match these for gain as accurately as we can. So I need to buy something like 20 each of these really to get a good stock of them, and then we should be able to find 5 that reasonably well match each other. So those, we may end up getting some pulls from China. Sometimes I think they're more reliable than the real ones. Yeah, real. But we do have the gain tester. We also have the power transistor tester for current, and we have the voltage tester. So we should be able to determine we have some good ones. I have bought some before, so I'll probably go back to one of the suppliers I've used previously. Do we need to check anything else? We do. We have this transistor, which is short base collector, okay, 2SA940. And the complementary one on the other side, this is the one that's actually exploded. 2SC2073. So I've added those to the shopping list. The quantity is the amount I need of each one. That won't be what I buy. I normally buy packs of 10 or something like that. Now, we at least should check the other power resistors, like we can see one there. I think that is the only other power resistor. We should check the diodes and the transistors that are still on the board, okay? Op amp down here, you can't really test it without removing it, and I have those in stock anyway. This looks like it's just across the relay, so I'd imagine that is okay. In fact, you won't be able to read that. That'll read like short because it's across the winding. as I will show you. Well, it reads very low. Okay, so that'll be okay. I have them in stock. What else do we see? This chip, this is the Protect IC C-1237HA. I have those in stock. They fairly often fail and they're common. So we have some diodes and transistors here. Let's have a look at these. And I'm in diode mode there. So 10407s, I have these. It's open that way. Yeah, reads good. Reads good. How about this transistor? 2SA1015. This is a PNP transistor. Let me see if I find the base. It might be in the middle. Doesn't read anything that way. Go this way. Diode junction. Diode junction. That was slightly higher reading. That'll be the emitter. Negative to the collector. Voltage reading open. Okay, so that reads good in circuit. This one, well, 5401, it tells us there the port. 2N5401. What are you? That is like very low. That reads even lower. That reads bad. So we'll take that one out. Yeah, that's gone. I've got a bag full of those in stock, but I'll just make a note of it on the list of casualties. So moving forwards again, we have these two transistors complementary. So the B will be a 2SB649, that will be a PNP, and the D will be NPN, I'm pretty sure. I'm not sure if these actually have the base on this end, which is where you'd expect it to be on a power transistor, but we'll have a look. So it reads nothing like that because it says PNP, but I've got the black on here, that reads like a diode, and that reads like a diode, okay? So it's probably base collector emitter the other way, reads open like that. Black on the collector, of course. So let's look at this one. Yeah, same sort of pin out. The red to the collector, which is the normal bias for an NPN. Those look okay. And I say they were the driver transistors, no, sorry, pre-drivers, because the drivers were bolted to the heatsink. The one here, this will be the one which balances, so this will be effectively the bias. Usually an NPN transistor. In fact, it says D again, yeah. Oh. This doesn't look good. It's a good job I left my solder sucker on. You can probably hear it in the background because that needs to come out. H669. I've seen these with a H marking rather than a D. I think I have these in stock. That's a bad transistor, okay. Now I have some H882, but not the 669. I'm going to put one of those, but that's the same as that one. I'll buy a bag, so because that's gone, in case anything silly goes on later, I'll already have that one. So I'm going to order this one as well, which is the complement B649. So we need to keep working through here because we're still finding bad components. Look, here's another load of the same type, okay. And then before that is the op amp and some diodes. How did these look? So these two are the NPN ones. That looks okay. Yeah, open from collector emitter. This one. That looks certainly not okay. This will be the PNP complement. That looks okay. That is certainly not okay, so good job I put the B649s on the list. May as well take those out, then I won't forget they need changing. And then we're back basically to the front end of the amplifier now. So diode looks okay. Looks okay, but they read different actually. That could be just how they are in circuit as to why they read different. Reads open that way, okay. Couple more over this side. How do these read? Oh yeah, one of them reads different as well. Okay, must be across a resistor somewhere. Well, that's a strange thing to say because they're in series there, but this point here may be connecting to somewhere else underneath. Although it doesn't appear to be. I can see there and there. Okay, well, if there's a problem with the diodes, I've got one M4007s, okay? Is anything else blown up? Well, we could check the capacitors, we could check the resistors. This we can't really test, but I have them. But I think I can see two ways forwards with this once we get some parts. One would be to rebuild the amplifier, put everything back in, and just put one pair of output transistors in and just run it at low volume, just to see, do we get any audio out? If I hear something, that's fine, switch it off and then put all the transistors back in. The reason being that the output transistors will be the most expensive part, and we don't want to blow a whole set of those up again. Yeah, really we don't. The other possibility, I think I'm more inclined to do this one, is to rebuild the amplifier with everything back on and then use the curve tracer and just go through all the semiconductors working back to see if I see any difference. If there's some problem with a resistor or a capacitor, you'll probably see the difference just by checking on all the semiconductor junctions. So also all the pins of this IC, all the pins of this IC. And if I don't see any difference on the curve tracer, I would then be inclined to power it up. But I think to do the curve tracer test, we need to fit everything back on. Otherwise, we may induce differences ourselves. Okay? So let me go through the shopping list and figure out how much it's going to cost to repair this thing. And I'm just doing some shopping now. I found these. So look, €16.50 plus another best part of 3. And shipping, okay. Original imported 2SA 1943, 2SC 5200 with 7 pairs. So it's an entire amplifier PCBs that have probably been salvaged from something. I'm interested to order one just to see what I get. Yeah, just to see what I get. Or whether in actual fact they just send the transistors and they don't send that. Yeah. Matching plates. So plates means circuit boards, really. Let's see what we get, okay. If it came with something like that, which I think it probably won't do, they should be matched. Let's see. I can actually find cheaper for new, but then I think, oh, are they real? Okay. And these look like the right sort of resistor. 3 watt. Yeah, wire wound resistor, fuse, winding. I think these are fusible resistors. They're the same colour, if that means a lot. 0.470, 173 for a lot of 10. I'll get 2 lots, I need 12 anyway. So that's 346. And there we have our shopping list. So 1940 for those. Okay, 7 pairs. See how we go on, see how they match game very well. Should be good enough at least to test the amplifier, okay. These are the resistors. I got 20 of those, then we saw that. Okay, 346 for those. So about €22 there roughly. Again, I can get these as 10 pairs, okay. €26. 10 of these ones, or the 4, 30, about €32, 33, something like that, if we add up all the rounding up. So somewhere in that region. I'm sure that'll be fine for the customer, obviously plus labour. So I'll get that stuff ordered and then we'll continue with this. Well, we have an Epilogue here, so I've contacted the customer, sent him a photo of the bag of burnt components and the PCBs, and I said cost of repair is €100. Okay, that should cover the cost of the parts. I may have to buy more of the power transistors to get some matching ones, but if I do, well, I've got more in stock, so it's not really a problem. They just become stock. I make a little bit less profit on this one, but then more profit on the next time I need some. Yeah, so I thought that was quite reasonable. He asked me, is this 2 times 600 watt or 2 times 1200 watt, this amplifier? And there's nothing to tell me in actual fact. It's I can't find a service manual or even a user manual for it, for the specification, so I don't know. But looking at it, with the 5 pairs of power transistors, okay, on each channel, this is a class AB amplifier, so it has a single voltage rail. I've looked at the large bulk capacitors. I haven't measured it. I could measure it on the working channel, but I would say this runs at around about plus or minus 90 to plus or minus 100, something like that. So it could theoretically handle about 600 watts per channel or so into 4 ohms. I think that's probably what this is. So CA-1200 means 1200 watt, the model, if that relates to the actual power. Yeah, although for example I remember AMD CPUs didn't relate the model number to the clock speed. Okay, so it doesn't have to, but I think this probably is 2 times 600 watt into 4 ohm, and it has a bridge mode. It's set to stereo at the moment. That's how I tested it with one working channel. It has bridge mode, and I would say that's 1200 watts into 8 ohms. Okay, that's quite normal for a bridge to be twice the impedance. Otherwise it'd be 4 times the wattage. Yeah, it's 8 to 2400 watts. So I'd say it is 2 times 600. And he said to me, oh well, I thought it was 2 times 1200. He's got this from somewhere. He says, given the weight of the unit versus the output power of the unit, don't repair it. We don't repair it, he says. And he then went on to say, well, do you want to keep it for parts? So he's very good like that, actually. Don't repair it, do you want to keep it for parts? So in that case, I'll say, yeah, I'll take that, thank you very much. That'll cover the cost of my time. So this one's mine now. I can use it for parts, or just keep it on one side. It has one working channel. Decide what to do with that. Okay, so that's the end of it. So you won't see it again, at least not for the moment. I may decide to repair it to recoup my money, or rather time. Okay, so chat about it down there. Hope you enjoyed it. It was a nice diagnostic session, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.